there's definitely something coming up for you guys that are interesting. Right? And here. So again, hopefully you guys can see the weekly schedule here. So again, the notes are right here for today because we're not really doing notes all week, but so we just got some notes today and some notes from Friday on there. What's up, Nick? All right. So first off, Wednesday, you guys have case testing, and I don't know, the juniors aren't doing a lot, but mainly the sophomores and stuff and freshmen. But there is case testing on Wednesday, so that's really going to disrupt our schedule. So we're probably not gonna have regular classes, but you guys should have plenty of time to get some work done. To be honest, probably not gonna have a lot of work for chemistry, assuming you do your stuff today. If you do your stuff today, shouldn't have anything to do tomorrow. Shouldn't have anything to do on Wednesday. Wednesday could be a good day to get caught up. Wednesday could be a good day to get some college class stuff done. Again, assuming that you are working hard in the meantime. If you are doing case testing, it will go to about noon. Then you have kind of the rest of the day to do whatever you need to do. Again, mostly, no. I don't know what the schedule is exactly right now, but no, there's not going to be any like here with me for chemistry. You guys are going to kind of be on your own for that day, but I don't know exactly how that's going to work yet. We did it last time, if you remember, back in November, but it'll probably look a little bit different this time. So again, no new material, and you should have time to get caught up on other stuff, whatever that stuff is, due to case testing. Probably not gonna have most of your classes at all on Wednesday. All right, so again, quick check-in. Ionic bonding notes, which we're going to start in just a second. And then there's a little worksheet. It's going to be a quiz, but it's not a quiz. It's a worksheet. I'm allowing you to do it 3 times, not averaging your score. I'm doing the highest score you get. So if you make mistakes, you can try it again. It's not going to average your score. It's not a quiz. It's just a worksheet. So no penalty like normal on it. All right, so Tuesday and Thursday, we're going to do our flashbacks, which we're going to kind of start doing that. You should have a little bit more time to do those. Again, dual credit kids, still like for you to do those. They take about 5 minutes, okay? Hopefully, 5-10 minutes. All right, now real quick, especially for you juniors and sophomores, starting tomorrow, we are going to start doing some ACT lessons, very specific lessons, and they're interactive lessons, and they come from Kaplan. Kaplan is an actual resource that Boone County schools have bought in order to help study for the ACT and let kids do better. So we are going to be focusing on the science part, obviously, but we are going to be starting that this Tuesday. If you're in dual credit, I'm going to exempt you like normal. However, I encourage you to check out those lessons. I will be making videos just like I am right now. I encourage you to check out those lessons to learn a little bit about the ACT. The lessons are going to be interactive, meaning that like I'm going to tell kids that, hey, click on this link and start doing that for 5 minutes. All right, let's talk about it. All right, click on this link, do that for 5 minutes. Let's talk about it. So the lessons are going to be interactive, and everybody's going to have access to everything. So even if you are dual credit and you want to do it at night or you want to do it on the weekend or whatever, again, I'm going to exempt you to where you don't have to do it, but I would check it out just to do better on the ACT. And I promise you that if you guys actually practice what we do for the next 4 weeks, your science score probably will go up a little bit, okay? Maybe a lot, okay? But again, we're going to practice certain strategies, and we're going to talk about what's good thing to do, what's not good thing to do on a science test in order to try to hopefully do better, okay? And again, to me, I would love it if you guys all went to go be chemists, but to me, I want you guys to go to college for whatever you want to go to college for. And the ACT is going to be a big indicator for getting into college and getting the scholarships you guys want. The ACT is kind of going away a little bit, but it's still a really, really powerful tool for you guys to use to your advantage. Okay. So if you can get a good score on that, you'll be more competitive compared to kids who don't take it or kids that don't get good scores. And that's what we want you guys to do. We want you guys to be competitive for your colleges, okay? Especially if you're going to go to a big fancy state college or private college and things like that. All right. Anyways, we're gonna get into ionic bonding today, and I'm gonna be bouncing back and forth between the notes and the whiteboard thing, so I can draw stuff. So you'll have to bear with me on that. But today is gonna be a pretty simple lesson, talking about ionic. We're gonna go kind of quick on this because you have the notes, but also because a lot of it is kind of review. Alrighty. So today is we're going to be focusing on the formation of ions in order to talk about how or why atoms react the way they do in order to do chemical reaction. And this is really kind of starting the actual reactions themselves and, you know, kind of looking at that information. So for example, pyrite. Pyrite is the iron sulfide. So you see the iron is Fe. That's a Latin word for ferrous. But so a lot of elements have Latin symbols and Latin names because Latin has been around for a really long time compared to English. And certain elements were very, very common. So, you know, the Latin and Greek people gave them names. And so pyrite is iron sulfide, FeS2. It's a very common mineral. And when you strike it, it does create a spark. And is oftentimes mistaken for gold and has a nickname of fool's gold. You can find it just on the ground, and it's got a little shine to it, and it's got a little lust. You know, it definitely kind of looks interesting. With that, so it's called fool's gold. This is an example of a crystal structure, and we'll talk more about crystal structures later. But crystal structures are when ions are bonded together, and you can make crystals, and they can make really cool shapes. And oftentimes they can make 90-degree shapes. A lot of people say things like 90 degrees is not part of nature. Nature wants to be rough and weird. Well, when it comes to crystal structures of ion and compound, oftentimes they are 90 degrees. They do look unnatural. They don't look like nature, so to speak. But you know that's because they are crystals. Crystal can have very sharp lines. And even kind of what diamond look like sometimes is diamond is crystal structure, and you can shape it to very fine lines and things like that. But sometimes they are found in nature that way as crystals. So very first thing we need to understand before we talk about the compound how they're formed is why ions are formed. So we talk about valence electrons. We should remember how to find valence electrons. Remember looking at the periodic table. You can do the whole 1, 2, skip a few, 3, 4, 5, 6, 7, and 8 for valence electrons. Remember that hydrogen is or helium is kind of weird. It does not have 8 valence electrons. It has 2 in that first ring. So again, valence electrons in the highest energy level, the last ring of the atom, and the number of valence electrons determine the chemical properties of the element, how it's going to react. Okay? It also corresponds to the group. So if it's a group 1 element, it's going to have 1 valence electron. Okay. Okay. So valence electron in review. So look at this Bohr model here. So real quick in the chat box, what atom is this? In the chat box, what atom? What element is that? I probably should look at your comments. Anybody else? Well, we got different answers. We got some similar answers. Okay, we got a lot of people saying. We got a lot of people saying sulfur. How or why do you know it's sulfur? Schubert. But then autocorrect. So all right. So how do you guys know it's sulfur? Yeah. So it's a 16 protons. You could also look at the neutron, but it's a 16 proton. How many valence electrons does sulfur have? It's in the drawing itself. Valence electrons? It's in the drawing. How many electrons on the outer ring? Yeah. And so again, remember remember that when we are drawing the atom, we want to do single first and then double them up. Okay. So on the first ring we have 1, then we can put 2, we double it up. Remember, electrons don't want to be next to each other, but we can double them up because they can move in opposite direction next to each other. So they are still staying away from each other even though they are doubled up. Okay. And so the second ring can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, space them out as much as possible, but you do want to start doubling on 5, 6, 7, and 8. So on this last one here, we got 1, 2, 3, 4. We double on 5, we double on 6, and then we have 2 empty spots. So again, we have 6 valence electrons there. And that's going to, act like that. All right. So the octet rule, again, means that it can form 8 valence electrons for the an octagon, octopus, has 8 valence electrons. And when it has 8 valence electrons, the atom is going to behave like a noble gas in that last column. Okay. And behaving like a noble gas is when it's stable, when it's calm, when it's done reacting, is when it reaches the octet, when it has 8 shells or 8 electrons. So if I go back to this drawing here, you can see that it has 6. I could lose all of those. When I lose those 6, I'll have 8 in the next ring, right? That is octet. I could lose 6. What's easier, though, is I can add 2 electrons and get 8. And then I'll have a full shell. The sulfur will be happy. Sulfur will be done. So the sulfur could lose 6 or gain 2 electrons. Well, common sense, it's going to be easier to gain 2 electrons than to lose 6 of them. Okay, and again, it doesn't have a brain. It doesn't think. It just does what it needs to do. And sulfur is looking for 2 more electrons, or it's looking to get rid of 6. It's going to be a lot easier for sulfur just to get 2 more. Okay, and so that's just a natural thing for sulfur. That's what sulfur does. Okay. All right, so atoms that tend to gain electrons are going to be your nonmetals, and we talked about that last week on parts of the periodic table. Nonmetals want to gain electrons, and so when they gain electrons, they're going to become negatively charged because electrons are negative, and they're getting more of them. Atoms that are going to lose electrons are going to be your metals, and when they lose the negative, they're going to become more positive. Okay, and so you have very often you're going to have a reaction where the metal and a nonmetal are going to pair up with each other because the metal says, hey, nonmetal, you want my electron? Sure, let me take your electron. Then the metal will become positive, the nonmetal will become negative, and they attract to each other like a magnet. Okay, and so quite often you're going to have a metal that bonds up with a nonmetal, and that creates an ionic compound, an ionic reaction. Okay. All right, so how a cation forms. So again, an atom's loss of valence electron produces a cation. Cation is a positively charged ion. The way I remember that is the word cation has a T in there for a plus sign. So a cation is positively charged. Okay, so a cation is an atom or a group of atoms with a positive charge to it. Okay, and then the name of the cation is the atom name followed the word by the ion. So for example, a sodium ion. That is a sodium cation. Okay, so we don't really change its name. It's just sodium ion. Lithium ion on there. So the way that we kind of represent this, though, is we draw the Bohr model, and then we draw a bracket around that element, and that tells us that, hey, watch out, lithium had lost an electron because it could have been a bracket. And it lost 1 electron, so it's a +1 charge. So this is lithium with 3 protons. It had 3 electrons. Lithium could gain 7, or it could lose 1 and be like hydrogen, or helium, sorry. Okay, so again, either gain 7 or lose 1. It's going to be a lot easier just to lose 1. And so in this one, we lose that electron, it's gone. And now lithium behaves like hydrogen, or helium. It is not helium. It's 3 protons. It's still lithium. Okay, and it lost a negative electron, so it is a +1, and we put a bracket around it, and then that tells us this is a lithium ion, not a lithium atom. The atom is going to be reactive. The ion is stable, is happy, is calm because it's acting like helium when it's done with that. Okay. All right, so and again, it's acting like a helium atom. Again, here's a picture of it, but it's not helium. Okay, it has 3 protons. All right, so cation charge formed. Again, group 1 is going to be a +1 charge. Group 2 is going to lose 2 electrons, so it's going to be a +2 charge. Just, you know, that should make sense the way that. Okay. All right, anions. Anions, I think the word anions has an N in there for negative anions, negative ions. So again, they are a group, or they're going to gain electrons, and so therefore they are going to become negative. So it's an atom or a group of atoms with negative charge. Now here's the naming rule for this. This is kind of weird. An anion is going to end its name with "ide." You guys have heard that before. Okay, you guys have heard of things like, you know, carbon dioxide, oxide. Oxide is an oxygen that is an anion, not the atom, but an ion. Okay. All right, so for example, here we have selenium. Selenium has 6 valence electrons, 1, 2, 3, 4, 5, 6. It wants to gain 2 more to have the octet rule. So we add 2 more electrons, there's a red one there. We put it in bracket to say that it is an ion, it's done reacting, and it is a -2 charge. It's now negative by 2 because it added 2 electrons. Again, we're not changing the proton or the neutron. We're just changing the last outer electron. And selenium, or that ion, seleniide, it behaves like a krypton because it has 8 valence electrons on there. Okay. So again, all the atoms want to behave like the noble gas. Okay. Again, they can go backwards to noble gas or they can go forward to noble gas, but they want to behave like a noble gas in order to be calm, stable, and done with their reaction. Okay. So again, atoms that are in, or elements that are in the 5th row want 3 more electrons, so they are a -3 charge when they add 3 electrons. Elements in the 6th column want 2 more electrons. They have 6. They want 2 more to reach octet. They're -2. And the ones in the far right group, in group 7, they have 7 valence electrons. They want 1 more to reach octet. Again, here are common names. So a fluorine ion is called fluoride. A chlorine ion is called chloride. Okay, so this is what's in your toothpaste, fluoride. It's calm, it's stable, it's done reacting. Okay, we're not putting fluorine in your mouth every day you brush your teeth. That would be horrible and you probably die. Okay, we're putting fluoride into your toothpaste, and that is a compound to help polish your teeth. Okay, chloride. Okay, bromide, iodide. This is 2 of them, 2 elements put together called hydroxide, hydrogen, oxygen. They are an ion, ide. Okay, I'm not going to ask you to memorize these, but there are going to be some that are super common that you probably already know. Again, oxide is super common, carbon monoxide. You probably heard those before. Nitride. Okay. And then there are some other ones that are groups of atoms that we're going to talk about later called polyatomics. All right, so real quick, I want you guys to do this, and I'm going to do it with you. Okay, writing a symbol with the names of ion. So the beaker in right shows a common iodine vapor. So why don't you write the name and the symbol of the ion formed? So just like we did before, okay. Let's try this real quick. What is the name and the symbol? So put it in the chat box. I don't think you could do superscripts, but you can just say it's going to turn into this with this. It gained 1 electron. And then I want you to do strontium. It's going to lose 2 electrons. So I'm going to do this with you. Okay, so I want you to do it in the chat box. What is ion? What is iodine? What does it turn into when it gains 1 electron? Let's see here. Do this. Negative 47. No, it's not. It's that is 71. I'm still not very good with the pencil, with the pen. 1, 2. So what? All right. So what does iodine turn into when it gains an electron? I need to see some stuff in the chat box. So that is iodine, and again, I did not draw all the rings. Okay, iodine had 5 rings. I just drew the last ring just to make my life a little easier. So iodine is going to close, kind of. So again, this is iodine. It's going to gain 1 electron, and that electron is going to go here. It's not going to be a cation. It's going to be negative. Okay. So just to make this a little bit quicker, 1, 2, 3, 4, 5, 6, 7. Again, it's going to gain 1 more. Okay. It's going to be a negative charge. Oh man, I need to work on my handwriting. Going to be a negative 1 charge, and that is going to be called iodide. Iodide. Okay, and that is an anion. It is negatively charged. It is negative 1 charge. Okay, so it's an anion. It's negative. Okay, and that is iodine. So what I would ask for you guys to write in your chat box, I would say something like iodide. You could also write I1 negative. If you want to do the bracket, that would be cool. If you want to type in the brackets, bracket I, negative 1. And you can also type in the name here. So that's what I would have typed into the chat box. So if you want to try that real quick, try to type in this right here. Try to type in that just to see if it works with the brackets. Can you guys type in the brackets? Can you guys type in bracket? Yeah, there you go. Perfect, Jordan. That's awesome. Yep. So that is the iodide. Oh, I like that, Owen. That's a good idea. So I want to put that little caret to show the charge on top. That's good. Perfect. Cool. All right. Yep. So it's a negative 1 charge because it gained an electron. All right. So let's try the same thing with strontium. Yeah, let's try strontium real quick. So strontium gained 2 electrons. Okay. So what's strontium going to be? Good. Yep. So there's going to be no change in the name on there. And it is a cation. We don't have to call it a cation. We can just call it a strontium ion. Because we know that it is, because we say its name like that, we don't have to change its name or anything. It's pretty easy on there. All right, you guys are not writing down the right names though, or the right symbols. Yeah. ST. I don't think there is an ST. So strontium is S, not S all by itself. That's sulfur. So strontium is Sr. It's on the periodic table. All right. So what would be the charge for strontium if it gained 2 electrons? Oh wait, I'm sorry. Strontium lost 2 electrons. So what would be the charge of strontium if it loses 2 electrons? So it's not negative. We got anybody catch it? It's going to lose 2 electrons. So if it loses 2 electrons, oh, not 12. So if it loses 2 electrons, strontium is going to become 2 positive. Remember, electrons are negative, so if you lose your negative, you're going to become positive. And so that is a strontium ion. And we do like to put it in brackets because this is not the same as this. Okay, that's really important. Okay, those are not the same on there. Okay, this tells us this is the atom, and it's still super reactive, and we got to be careful. And this is the ion, it's pretty much done reacting. Okay, and that's a big difference. And again, of course, we would probably put the charge up there just to let us know. Okay, so super reactive, going to blow up in your face if you have that atom, and it probably would. And this is the ion, pretty much done. It will bond up. So again, this positive is going to go up and bond up with something like oxygen. Okay, oxygen would be 2 minus. Okay, and these guys are going to love each other. Okay, because they're 2 positive, you're going to bond up with 2 negative, and you're going to end up with a nice little compound there, strontium oxide. And again, that's how we would write that too. So strontium doesn't change its name. Oxygen changes its name. Ooh, messed that one up. So we get strontium oxide when strontium and oxygen get together. Because again, positive getting together with a negative on that. I'm getting ahead of myself. That's an actual reaction there. We're not really there yet. So, all right, let's erase all this. Then we will. I think there's another quick little question on there for you guys. All right, so let's go back to the screen. Back to the notes real quick. All right, so we did that. Analyze atom gained electron. Name of the anion is an ide. Yep. So we said that already. So if it gains an electron, turns into ion, it can change its name to ide. If it loses an electron, form positives, can be a cation. We don't change the name; it just stays the same. But we do like to say ion, like sodium ion, whatever. All right, yeah. So iodine with a +1, strontium with, or iodine with -1, strontium with a +2. Actually, we could actually bond up. Let's do that real quick. We can actually bond up the strontium with the iodine as well. So get out the whiteboard here. So if the iodide is +1, or -1, sorry, and we want to react it with the strontium, which is +2, right? These plus and minuses, they would love each other, okay? Because again, they're going to be attracted to one another. Opposites attract. And so, but how many iodines do I need to bond with strontium? Strontium has a +2, so how many iodines do I need? So you guys can just say it out loud or put it in the chat box. How many iodines will I need to react with strontium? -1 and a +2. Will 1 do the job? Will 1 react? So again, 1. So strontium is a +2. So it's looking for 2 iodines. So iodine plus is -1. But if I put another iodine here, okay, the 2 want to react with 2. Okay, so 2 little magnets. Okay, so the strontium is looking for 2 negative particles, and so strontium is 1 and 1. So iodine is 1 and 1. So strontium want 2 iodides to react in order to bond it together. Again, they're like little magnets. Okay, so if strontium is a positive magnet and it's got 2 of them, right, then it's going to look for, it needs 2 iodides in there, right, in order to bond up with the strontium. Right, we'll do that a lot more later. But again, they are positive and negative, and they can bond together, and that forms. And again, the name of it, strontium doesn't change its name, and then iodide does change its name to iodide. That'd be strontium iodide when they bond together. All right. Again, I'm getting kind of ahead of myself on that. All right. So I think that's it for notes. Yep, that's it for the notes. So that's it. So today, what we're going to do here, we got about 10 minutes left in class, is we're going to work on our worksheet. This is called Forming Ions. Again, this is a quiz worksheet. Okay. And I do want to kind of walk you through it real quick because there's a couple of things you need. So again, here is me trying to give you guys some help with the names. Okay. And again, I'm giving you the abbreviation, and it's gonna end in ide, oxide. So it's not oxygenide, it's oxide, sulfide, fluoride, chloride, not chlorinide, just chloride. So they do abbreviate themselves a little bit. Okay. Again, you have a periodic table here, and then you're gonna have some questions here. So the question is just this row right here, but check this out, highlighted, really important. Make sure you scroll all the way across the table to answer all drop-down menus. There are 9 per row. So sodium, what group is it in? Look at the periodic table, it's up here. What group is sodium in? Okay, so you're just gonna find it. Okay, whatever. And then you need to scroll all the way across on this, okay? You need to answer all these questions here, and then go from there, okay? Now, this being a quiz, don't submit it until, or don't forget to submit it, if that makes sense, okay? There's no time limit on this. You have 3 attempts to do this. The highest score will be recorded. So if you messed up the first time, don't worry, you can take it again, okay? This is not a quiz, this is just practice, this is a worksheet. And then Canvas should grade it automatically and tell you what you got right, what you got wrong, okay? So that is your assignment for today. Okay, thank you, Dobie. That is your assignment for today and tomorrow and Wednesday. It should not take you that long. You'll probably finish most of this right now. We won't do a breakout group. You guys are more than welcome to talk to each other right now, you know, and ask me questions as well. I'm gonna go ahead and stop the recording for those kids that are absent, just because I don't think a lot will happen between now and then. But as always, if you guys have questions, make sure you reach out, make sure you ask. All right. All right. So talk to each other right now in the class. You get one big class. Have fun. Show each other your cameras, whatever.